Lesson 13 is about common factors and the greatest common factor. We're also going to talk about multiplication word problems. Now, we've got some key vocabulary to start with. Common factor and greatest common factor. Let's look at common factor first. So if we had two numbers, let's say we had 12 and we had 15. If we want to find the common factors of 12 and 15, what we'd have to do is find out what our factors of 12 would be. Factors just mean what numbers multiply to get to 12. So we could have 1 times 12. Okay, we could have 2 times 6. We could also have 3 times 4. Okay, those are all of our factors of 12. So if we look at that, let's box 12 real quick. We've got 1 and 12, 2 and 6, 3 and 4. If we want common factors between 12 and 15, let's find out what our factors of 15 are. We can have 1 times 15. We could have 3 times 5. Those are our only factors of 15. We can box this for now to make it clear that that's the number we're working with. So the common factors between 12 and 15 are exactly what it sounds like, what they have in common. They both have a 1 in common. If we look, 15 doesn't have a 12 as a factor. Well, 12 also has a 3 as a factor, and 15 has a 3 as a factor. So our common factors between 12 and 15 would be 1 and 3. Using this type of definition where we have an example is a very good way to define a common factor. Now, if we want to define the greatest common factor, if we want to define the GCF, greatest common factor of 12 and 15, that would have to be 3. And the way that we could write that would be like this. The GCF, and then we're going to have both 12 and 15. So we're going to have a parenthesis and 12, comma 15. The greatest common factor of 12 and 15, we know their common factors are both 1 and 3, but the greatest between 1 and 3 would have to be 3. So the GCF of 12 and 15 is equal to 3, and we have our answer. We can report it just like this. The greatest common factor is just the biggest factor that both of your numbers, or all 3 or 4 or 5 of your numbers that you're comparing, have in common. Make sure you get these definitions written down in your notes today. Pause if you need to. Alright, now what we want to do is find the common factors and the greatest common factors of the following pairs of numbers. So 24. If we look at the number 24 and we list out the factors of 24, we could have 1 times 24, we could have 2 times 12, we could have 3 times 8, and we could have 4 times 6. Let's look at 30. If we have 30, we have 1 times 30, we have 2 times 15, we have 3 times 10, nothing times 4 will evenly go into 30, but we have also 5 times 6. And those are all of our factors of 30. Now we need to look for the common factors. The common factors between 24 and 30, well, they both got a 1. Okay, they both have a 2. They both have a 3. Okay, and if we look, they both also have a 6. So those are our only common factors, 1, 2, 3, and 6 between 24 and 30. Now if we want to find the greatest common factor, the GCF of 24 and 30, that would have to be equal to 6, because 6 is the biggest number that they both have in common. Let's look at another one. Let's look at the greatest common factor and the common factors of 24 and 7. Well, 24. Oh, we just did 24. Okay, if we just did 24, we can repeat that information. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. We just did that in the previous problem. 7. Well, 7. 7 is just, the only way we can get to 7 is 1 times 7, because 7 must be prime. So our common factors must be 1, and that's all. So our greatest common factor, the GCF of 24 and 7, so GCF parentheses 24 comma 7, will be equal to 1. And that's all that we have. We can go ahead and put a different color outline on that since we have blue as a background on the right. And we're all done with these two types of problems. Make sure you've got this information copied down into your notes. Let's look at our next slide. Key vocabulary, relatively prime. Two numbers whose greatest common factor is 1. So if we look back at our last problem, we know the GCF of 24 and 7 is equal to 1. Just did that one. So these two numbers, 24 and 7, we can say they're relatively prime because they are two numbers whose greatest common factor is equal to 1. Now this is a phrase that we'll use occasionally, and you need to know exactly what it means, because it just means the greatest common factor would be 1. Let's look at another problem. Let's find the greatest common factor of 72 and 90. Now this one's a little bit more complex. So what we want to do when we find the greatest common factor of 72 and 90 is to break these numbers down using a factor tree. So let's look at 72. If we take 72, I know 72, we don't need the circle yet, it looks like an answer. 72 is going to be the same as 9 times 8. We could have also said 72 is 36 times 2. They're going to get the same answer in the end. 9, factors of 9, 3 times 3. We want prime numbers here, remember. 8, if we break down 8, that's 4 times 2. And if we break down 4, that's 2 times 2. So what we get in our end are prime numbers of 2 times 2 times 2 times 3 times 3. Let's write that out. 2 times 2 times 2 times 3 times 3. Very good. Now let's go through the same process for 90. If we want to break down 90, I like to break that down by 9 times 10. 9 can be broken down, we just saw, as 3 times 3. And 10, it can be broken down into 5 times 2. So we've got our prime numbers. 2 times 3 times 3 times 5. Let's write that out. 2 times 2 times 3 times 3 times 5. Okay? Now when we look at this, what we're looking for is which pairs of numbers they have in common. So if we're looking for the greatest common factor, if we're looking for pairs of number in common, so prime numbers, we've got a 2 in common for both of them. 2 in common, very good. Okay, we've got a 3 in common for both of them. Can you see that? What other number do you see that they have in common? Hopefully you saw the other 3. They both have a 3 in common. So the last step that we have in this, we're going to say the GCF of 72 and 90, we're working with big numbers here, is going to be equal to 2 times 3 times 3, because those are the prime numbers that they have in common. So we multiply those together. 2 times 3 is 6. 6 times 3 is 18. So our answer must be equal to 18. That's our greatest common factor of 72 and 90. This was a different method we used. It's really effective when we have big numbers. Alright, looking at some multiplication word problems now. Harriet's score in the second game was the product of her first game's score and 25. If Harriet had scored 14,025 points in the first game, how many points did she score in the second game? Now in this problem, we're looking for some key words. Her score in the second game was the product of her first game score. Product. Okay, product, we know that means to multiply. So we can put our multiplication symbol there of her first game score and 25. So what we're going to do is we're going to multiply the first game's score times 25. We can put those parentheses next to each other. That just means multiplication. First game times 25. We'll write game in there. Make it a little bit more clear. She scored 14,025 points in the first game. So instead of saying the first game, we know how many points she scored, 14,025. And we're going to multiply that times 25 to find out what our answer is going to be. We can go through that math. That's going to be no problem, and it's going to tell us how many points she scored in the second game. 5 times 5 is 25. We're going to carry our 2. 5 times 2 is 10, plus 2 more gives us 12. We're going to carry the 1. Ooh, got a little email up there. You can see what's going on. 5 times 0 is 0, plus 1 is 1. 5 times 4 is 20. And carry the 2. 5 times 1 is 5, plus 2 more gives us 7. We're going to have the 0 as a placeholder. 2 times 5 is 10. We're going to carry that 1 this time. 2 times 2 is 4, plus 1 more gives us 5. 2 times 0, this is scratched. 2 times 0 is 0. 2 times 4 is 8. And 2 times 1, this one's scratched. 2 times 1 is 2. Make sure you keep your work organized as you go through. Looks like we'll have just enough room here to work. We've got a 5, a 2, a 6, a 0. 8 plus 7 is 15. We're going to carry the 1, and we get a 3. So we've got 350,625. We need a label. How many points did she score? She scored 350,625 points. Make sure you box your final answer. That's the product, the answer to the multiplication problem, and you're all done. Now in this problem, you don't need to write out this word problem if you're wondering about your notes because it has more than one sentence. Okay, but go ahead and write out how we found out what our answer is. Our lesson practice, we'll continue this more. If you have any questions, write them down. We'll be on page 49 tomorrow. Make sure your notes are completed, and I'll see you next time.